Gaussian elimination. In Gaussian elimination, we use what's called row echelon form, which is a stair-step pattern with leading coefficients of 1, and then the systems that are written in row echelon form can be easily solved by substitution. So when we solved using matrices in the last lesson, you got it in row reduced or reduced row echelon form, and it was where you had a diagonal of ones and then zeros above and below the ones, and then a constant column over here on the right side. What's different, however, is that row echelon form, you don't have zeros above the ones. It can be any numbers up here. And so row echelon form is where you still have a diagonal of ones and you have zeros underneath it, but the rest of the matrix can just be any number. So in this example, this is actually a great example of row echelon form. So let's put this in an augmented matrix. So for the first column, we're going to put all the x's, and so the first equation has a coefficient of 1. And if you notice, the second two equations do not have an x, so that column in the matrix gets a 0 for each of those. In the next column, we're going to put the y's, so the first equation we have -2 as the coefficient. In the second equation, the y has a coefficient of 1. And in the third equation, there's not a y, so that one gets a 0. For the third column, we're going to have the z's. So then we're going to put 3 in the first row. In the second equation, we have another 3, so 3 in the second row. And then our last equation, we have 1z, so we have a coefficient of 1. And then lastly, the very last column is always going to be your coefficients, your constants. So we've got 9, 5, and 2. And this is our augmented matrix. So if you notice, we're already in row echelon form. You've got a stair step going on right here. We've got a diagonal of ones, zeros underneath, and a bunch of numbers elsewhere. So here's what we can do. We can use the bottom row to figure out one of the variables. So if you look right here, we have the z column with a 1 in the very bottom row. So that's saying that z is equal to 2. So z equals 2. So now we can substitute z into another equation. So if you go into this equation right here, we'll substitute in. So we get y plus 3 times 2 equals 5. Solving that, we get y plus 6 equals 5. And then we have to move the 6 over. So we get y is equal to -1. Then we plug those two into the next equation right here. So we get x minus 2 times y, which is 1, plus 3 times z, which is 2, equals 9. Solve that. We get x minus 2 plus 6 equals 9. Then we get x plus 4 equals 9. Move the 4 over. We get x is equal to 5. So now we have all three of our variables for the ordered triple. So your ordered triple would be 5 for the x, comma, -1 for the y, comma, 2 for the z, and that's your answer. What if the augmented matrix is not already in row echelon form? The rest of the video is showing you how to get your matrix in row echelon form in order to do what we just did on the first example. So here's your cutout for this lesson. It's titled Gaussian Elimination. It says right here, your goal is to get the matrix in row echelon form, so it looks like this. However, go ahead and put your little brackets on it. That was not typed onto your handout. So Gaussian elimination is where we eliminate the variables or a couple of the variables by manipulating the matrix. And so here are ways that we can manipulate the matrix. We can interchange two equations. So in other words, if I wanted to, I can flip-flop two of the rows. So I could switch the first and the third row, the first and the second, or the second and third. I can interchange those. Okay, I could multiply one of the equations by a non-zero constant. So in other words, distribute into one of the rows a number that's not zero. Or lastly, I could add a multiple of one of the equations to another equation to replace it. So I could multiply an equation, then add that equation to another one, and then replace the one I was adding it to. So here are the steps. Step 1 says to manipulate the matrix to get a 1 in the upper left corner. So I'm going to do one of these three things to make sure I have a 1 up here. If I already have a 1 up there, then you're good to go. You don't have to worry about it. Step 2, manipulate the matrix to get all zeros underneath the 1 in the first column. So again, do some of these three things right here to get zeros underneath that 1. Step 3, manipulate the matrix to get a 1 in the second row, second column. So again, do one of these three things to get a 1 right here. Step 4, manipulate the matrix to get all zeros underneath the 1 in the second column. So one of these three things to get a 0 right here. Step 5, manipulate the matrix to get a 1 in the third row, third column. So again, do one of these three things to get a 1 in this column right here. Once you do that, we use the bottom row to determine the value of one of your variables. So this bottom row will tell me what that third variable is equal to, and then I can use substitution to solve for the remaining variables. So here's example 2. Go ahead and put this into your augmented matrix. So this is our augmented matrix, and to make this a little bit easier to communicate, we're going to label the rows. So this is going to be row 1, this will be row 2, and this is going to be row 3. Alright, so looking at your steps, it says to manipulate the matrix to get a 1 in the upper left corner. I already have a 1 in the upper left-hand corner, so that means step 1 is done for us already. We can move on to step 2, which says to manipulate the matrix to get all zeros underneath the 1 in the first column. I've got a 0 right here in the third row, but row 2 needs to have a 0. So my goal is to somehow make this number become a 0 by using one of these three ways to manipulate the matrix. The first thing is to interchange two equations. So I could switch out this row with another row. But remember, I want this row or this number right here to also be a 0, so it really won't do us any good to switch it out. So then the next one says to multiply one of the equations by a non-zero constant. So that means I would have to multiply the second row by something that's not 0 to make this number become a 0. That won't work. I would have to multiply by 0, but this says by a non-zero. So then I would have to do the last thing, which says to add a multiple of one of the equations to another equation to replace it. So if you look at row 1 has a positive 1, row 2 has a negative 1. If I add those together, it'll give me 0. So I actually don't even need to multiply this and add. I just need to add these two rows together. So what I'm going to do is add row 1 plus row 2. So let's write that out right here. Row 1 will be 1, negative 2, 3, and 9. Row 2 is negative 1, 3, 0, and negative 4. Add those together. 1 plus negative 1 cancels out to a 0. Negative 2 plus 3 gives me 1. 3 plus 0 gives me 3. And 9 plus negative 4 gives me 5. So this is going to be the new row 2. So let's go ahead and rewrite our matrix and replace row 2 with this right here. So again, I replaced row 2 with my new row 2. And now if you notice, I have all zeros underneath the 1, so I can mark off step number 2. Step Step 3 says to manipulate the matrix to get a 1 in the second row, second column. So second row, second column is this number right here, and I already have a 1, so I can check off step 3. Step 4 says to manipulate the matrix to get all zeros underneath the 1 in the second column. So my goal now is to get this number to become a 0. So again, let's label our rows. We've got row 1, row 2, row 3. And looking at our ways to manipulate, we could interchange two equations. Well, I don't have another equation that's going to make this become a 0 because these are not zeros. I could multiply one of the equations by a non-zero constant. Well, there's not a number that I can multiply by to make this become a 0 other than 0, and it has to be a non-zero, so that won't work. So lastly, add a multiple of one of the equations to another equation to replace it. So what that means is I could actually multiply row 2 by a number and then add it to row 3 to make it cancel this out to 0. If I want to cancel this to a 0, I need it to be a positive 5. So I'm going to multiply row 2 by a positive 5 so that it becomes a 5 right here when I add. So again, I'm going to multiply 5 times row 2 and add it to row 3 in order to replace row 3. So let's first start by multiplying 5 times row 2. So row 2 is the numbers 0, 1, 3, and 5. And I need to multiply it by 5. So I'm going to distribute that out. And we get 0, 5. 5 times 3 is 15. 5 times 5 is 25. And now we're going to add it to row 3. So let's write out row 3. So add row 3, which is 0, negative 5, negative 14, and negative 23. And let's add these together. When I add 0 plus 0, I get 0. When I add 5 plus negative 5, I get 0. When I add 15 plus negative 14, I get 1. And when I add 25 plus negative 23, I get 2. And this is our new row 3. So let's go and replace the old row 3 with the new row 3. So again, here's my new matrix, and all I've done is replace the old row 3 with the new row 3. All the other rows stayed the same. Even though I multiplied row 2 by 5, it was not to change row 2, it was only to change row 3. So row 2 stayed the same. So now I have it in row echelon form. And because it's now in row echelon form, I can now use substitution in order to solve. So let's look back at our steps. We did step 4. Step 5 said to manipulate the matrix to get a 1 in the third row, third column, which we already have because it's now in row echelon form. And then step 6 says to use the bottom row to determine the value of one of your variables, and then use substitution to solve for the remaining variables. So looking back, look at the very bottom row where the 1 is. It's in the Z column because remember this is going to go X, Y, Z, and then constant numbers. So here's the 1 in the Z column, so that means Z is equal to 2. So Z equals 2. Now I can use this information to plug back into or substitute into one of my other equations from the original problem. So here's the original problem, and if I plug in Z to this equation, that means I would still have an X and a Y that I don't know the value of, so I could not plug into this one. If you look in the second equation, I don't have a Z, so I can't plug into that equation. But if I look at the third equation, I have a z and only one other variable. So I'm going to plug into the third equation and solve for the y. So I would get negative 5y minus 14 times z, which is 2, equals negative 23. And now we're going to solve that. So then we get negative 5y minus 28 equals negative 23. And then add 28 to both sides. We get negative 5y equals positive 5. Divide by negative 5. And we get y equals negative 1. So we already found that z equals 2. Now we know y equals negative 1. So plug both of those into another equation to find x. So let's plug into this one right here. Or actually, we don't need to plug in the z because this one doesn't have a z, but we could also plug into the first equation with both the y and the z to find the x. But plugging into this one, we just have to plug in the y. So we get negative x plus 3 times negative 1 equals negative 4. Now solve for x. Get negative x minus 3 equals negative 4. Add 3 to both sides. You get negative x equals 1, negative 1. Then divide by negative 1 to get rid of the negative, and we get x equals positive 1. So there's our other part of our answer. So finally, we just need to write our answer in the form of an ordered triple. So it would be x, which is 1, comma, y, which is negative 1, comma, z, which is 2. And that's our final answer. Here are your secret questions. Solve the systems of equations using Gaussian elimination. Notice number 1 is actually going to already be in row echelon form. And then number 2, you will have to manipulate the augmented matrix to get it into row echelon form.